Ooh, Colchester. I was going to say Bridgeport, but it's not. Hey, g'day, it's Prezzo here. Thanks for joining me today. As you can see, I've got some new stickers on the board and I want to run through these with you today, just to let you know a little bit about each one of these people and what they do. Now, this first one, Von Industrial. Now, this belongs to a gentleman named Tom Utley. Now, Tom and I got to know each other because we tend to do similar things with brass etching to make nameplates. Now, Tom's one of these people who's taken this a lot further than I have, and he's recognised now as being one of the true experts in how to do this. Now, most of his most recent work is actually on Instagram, and he has a very cool Instagram handle. It's King Tutley. I'll put his link in the description below. He does have some videos on YouTube. He really has investigated and researched the topic and perfected it, as far as I can see anyway. And if you want vintage nameplates or even new nameplates made for any machinery, he can replicate it and produce very high quality work. Say for example you've got an old milling machine or a lathe or a bandsaw, he can create replicas of those nameplates which usually get a bit banged up and scratched and damaged, and you can see before and after pictures of what he's been able to do with that process. So check him out. And certainly if you're in the market for a replica plate for a machine, he's the guy to go to. Okay, the next gentleman I want to talk about is this one here, the Amateur Redneck Workshop. Now, the gentleman that runs this is named Harold. He lives in the USA. He does some really diverse work in the home workshop, and very similar to what I do in fact. And he sent me some of his stickers and I agreed to send him some of mine. And unfortunately, when Harold received my stickers, he put them with a bunch of junk mail, and well, you know, I'm not sure what happened, but they ended up in the bin. And this time I sent him some more, and I made sure that when he got the envelope he'd realise that they really were stickers and not something else. So here's a picture of the envelope that I sent him. But then in hindsight I looked at it and I thought, you know what, it really does look like one of those Reader's Digest letters that you get. So hopefully they went up. The next gentleman is a guy called Aaron Powter. Now, Aaron sent me 4 stickers. This one up here is DCT Teacher 1. Well, I thought I was Teacher 1 really, but I'll let him have that. This one here, DCT with his picture on it. We've got another one down here called Aaron Engineering with a picture of his beautiful Colchester lathe and his milling machine. And this one is actually not Aaron's sticker, but it's a website that he was promoting. Now, it turns out that Aaron and I went to the same tertiary institution to learn about education, or advanced child mining as I like to call it, but our paths sort of diverged after that, and Aaron ended up teaching in Victoria, the lockdown state, and I stayed here in Queensland. Now, if you're interested in what Aaron does, he does a mixture of CAD and CAM, some tutorials on Fusion 360, he does some manual and CNC machining, some workshop topics, so you know, all the good stuff, so check it out. So there you go, there's the stickers, the latest upgrade to the board, and today we're going to do something really nerdy and exciting. So let's check it out, see what it's all about. Oh, seriously? This is what I've been waiting for. Let me introduce you to the TouchDRO system. Now, up until recently, I didn't even know this existed. One of my YouTube viewers pointed me towards it, and as soon as I saw what it was capable of doing, I was hooked and I wanted to have it badly. Now, this is an app running on a standard Android tablet. This is a really cheap tablet, but the app itself is very good. But the app is useless without this little gadget here. Now, this is a Bluetooth enabled device which takes data from standard eye gauging scales and sends it wirelessly through Bluetooth to this app. And when I looked at this there was a couple of options for buying this Bluetooth enabled device. You could buy a kit of parts and assemble it yourself, and being a bit cheap, I thought that was probably the best way to go. But there was a pre-made option as well, and the gentleman that runs the store is called Yuri. His website's called Yuri Toys. I'll put the link in the description below and you can check it out for yourself. But when I went to buy the kit, Yuri said that I'd be better off to buy this pre-made board. It's much more reliable, works straight out of the box, and he agreed to send me this at the same price as the kit. So that was a good deal as far as I was concerned. And when I unboxed this and had a good look at it, I'm super impressed with the quality of it. And I've tried it out and it does actually work straight out of the box. So what I'm planning to do on my Bridgeport mill is replace these individual eye gauging LCD displays with the TouchDRO system. In today's video I want to focus on working out a way of mounting this 10-inch tablet on the right hand side of the Bridgeport mill. Now if you're right-handed, that's the hand you would use to actually punch in the numbers on the display here, so it makes sense to use that position. There are two existing holes already on the RAM on the right-hand side, and they match up with these hole centers here. And in my scrap box I came across this arm. Now this was originally for a DRO, and it was the one that I fitted to my Colchester lathe. I didn't need the arm because there was already a bracket on the back of the headstock, and I was able to rigidly mount the DRO display on that bracket. So the arm was surplus, and all I've done here is I've powder coated this silver to match the other accessories that I put on the Bridgeport mill. Now there were already these two steel fittings in either end. So this one here takes a 6mm pin, and this one here is the swivel bolt that fits through this bracket. So the pocket in the bracket here has been sized to take the arm, and it has a pair of washers that go top and bottom to pack that out to the correct size. So that will allow me to pivot the arm and put the display in a comfortable position for me to use. Now the bracket itself has been cast in aluminium, and I made one of these on the left hand side of the Bridgeport RAM to mount my work light. So this was just an adaptation of that existing pattern, and these two lugs here have been sized, as I said, to fit the arm. Now the back of the bracket has been packed with epoxy resin, so it matches the curvature of the Bridgeport RAM, so it fits nice and neatly in that position. So that's all ready to go on, and we'll look at that in a minute. Now in order to mount the tablet to this end of the arm here, I'm going to need some sort of a plate and something with a pin in it that will go through this 6mm hole. So I've got some 40mm aluminium bar stock, and we're going to use that to make the fitting that goes through this hole. And I have some 3mm aluminium sheet stock. We're going to use that to mount the tablet to. So the challenge here is how we get the tablet to mount onto that aluminium so that it's held securely and it won't fall out, but also we want to make sure we don't crush or damage the edge of the tablet. So that's what we're going to do today. These are the two holes I was telling you about. These were fitted, I'm guessing, at the factory. There's an identical pair on the other side of the RAM, and our bracket goes into those 1/4x20 holes, and these screws have been powder coated to match everything else. And that's the advantage of having your own home powder coating kit. And when I was putting the epoxy on the back of this bracket, I just spread it on. It's one of those metal filled epoxy pastes, and I screwed this down hard, let the epoxy ooze out of the back there. I checked to make sure the arm was level when I did this, and I let that set, and that now fits neatly all the way around there, because that section of the RAM is not flat. It's sort of a bit tapered and a bit curvy, but it does fit neatly now. Now if you don't have the ability to do metal casting at home, you could make this bracket, you could fabricate it out of steel or aluminium. You could weld it, you could bend it. You really don't need to do what I've done. And what we should be able to do now is to fit one of our thick washers on the bottom. And there's another thick washer that goes on the top. thin washer on that side, bolt goes through. Eventually. Now we've got another thin washer and a spring washer on the bottom. Alright, so that now pivots and we can get our display mounted on that. And that's the next thing. Let's get busy with that. Oh, I've decided to go about this backwards. I'm showing you the finished tablet mounting up here. Initially I was going to do this as a full build, but the video ran out to about 45 minutes. I thought no one's going to watch this. So what I'm going to do is I'll show it to you now, and we'll have a look at the back in a minute, and then we'll pull it apart and I'll show you some of the processes I use to make this. But just while we're here, you can see that I can move the tablet anywhere I want to within reason, and I can position it back away from the plane of the milling machine table, get it out of the way of chips and coolant and so on, or you can bring it up really close if you want to. So let's have a look at the back and then we'll strip it down and look at the individual bits. As you can see here from the back, there's nothing terribly difficult about making any of these parts. It's all basic machining, so a bit of drilling, a bit of tapping, some lathe work, a bit of sheet metal work, some finishing and so on. But it does hold the tablet really securely. There's no way in the world that's going to fall out of there, but at the same time it's sort of not damaging anything on the frame of the tablet. Anyway, let's get this apart now and look at some individual parts and how I made them. Here are the individual parts broken down from the assembly, and as you can see there's really not that much to it. Now the materials that I used for this are, first of all, this piece here. This is a 40mm square 6061 alloy. I've got a ton of this stuff as offcuts, so it was just convenient and roughly the right size, so I used that. That's for that particular fitting there. The little buttons that hold the tablet down to this sheet metal frame, this is 30mm diameter acetal or acetal. I call it acetal, really not sure what the pronunciation is of that. But this stuff's lovely to machine and it's soft-ish, so it doesn't damage the edge of the tablet frame. Now this sheet metal component here, this is 3mm thick aluminium sheet. Now I liberate this stuff from the skip down at my local sheet metal workshop, and it's free. The downside is that even though it has this plastic film on it, which is normally to protect the finish, because it's been thrown in the skip, it's sort of all scratched and damaged. But I'm not going to complain because I get lots of it for nothing. So this piece of stock started off oversized. I set this up on my surface plate, and using the height gauge I just went around and measured off the correct width and height. Now I'd already squared up two edges by draw filing and just checking with a square and so on. And the overall dimensions are really not that critical. One of the things I wanted to be sure of was that when I fitted the tablet onto this piece of sheet metal, that I could get the buttons sort of close to the corners. And one consideration if you're thinking about doing this, you want to be careful where the on-off buttons and the actual volume buttons are on your tablet. So in this one, they're close to this outside corner here, and you want to be sure that when this is all assembled, you're not going to cover up that power button. So once I had the sheet metal work marked out, I just simply drilled the four corner holes which hold the buttons in place. I didn't do anything with the center of the sheet metal at this point. I wanted to make sure I had the fitting that screws to that all made before I marked off the hole centers for it. So this was just a bit of draw filing, cleaning it up after on the edges, just using a Scotch-Brite wheel. And once I had that, I basically put that aside until we got the center fitting done. So for this adapter or center fitting, I started out with some stock that was almost the correct length, so I cut it a little bit oversized. This was set up in a self-centering 4-jaw chuck, and the spigot here was machined first, and then I drilled and tapped for an M6 screw, because that's the size of the hole in the pin on the arm that holds the DRO in place. Once I had all of that done, cleaned it up, I brought it back to the surface plate and I marked out the four corner hole positions and center punched those centers. Now, of course, if you've got an indexing head or a rotary table, that would be a much more accurate way of doing it. I have both of those things, but at the end of the day, for what this is, it wasn't worth breaking out that gear. It was just a case of careful marking out, center punching and drilling. Now these are M5 clearance holes for M5 screws, and they don't have to be that size. 3mm would work fine, or whatever imperial equivalent you want. So that part was tapped all the way through, M6 all the way through, and that way I can fit an M6 screw from the back to hold it onto the DRO arm, and on the front I could use a countersunk head screw to hold the back plate against this particular fitting. You don't need to do that. If you've got 4 corner holes, you really don't need the center one, but it was just a convenient way of holding it all together while I transferred these hole centers through. Now, when I said I transferred these holes through onto that back plate, I didn't use any transfer punches, sorry. Now, a lot of my viewers have been encouraging me to buy those, and believe me, I was all set to do that. I had it in the budget, just about to do it, and I got an email from a company called Hare & Forbes. Now, here in Australia, they're a bit like Harbour Freight, and I am on their email list, and I get these offers every now and then. They call them mates rates. And in the email there were 2 sets of these, a metric and an imperial set, and they were allegedly 20% off. Now, I don't know about you, but as far as I'm concerned, mates rates is a 6-pack for a small item and a carton of beer for a large item. But I can tell you now, these cost a lot more than a carton of beer. So the 2 sets that I bought, I reckon they set me back about 5 cartons of beer. But I love them. They're pretty, and they got this little spinny bearing in the center. This arm at the top here has got a detent in the center, but you can slide it either way. And they're very Tom Lipton-esque, so I was happy to have them, but sadly no transfer punches, sorry. These little buttons were turned on the lathe, but if you didn't have a lathe, you could do this on a 3D printer, I'm guessing. And they're made of acetal or acetal, and there's no real trick to the making of them, except for a little flat which has been milled on one side. Now, I'm not sure if you can see that. There it is. Does that show up? Yeah, you might be able, there it is there. So there's a little tiny flat there that's 1/2 millimeter deep, and that's specifically to act like a cam. So when these buttons are screwed down, you can twist them ever so slightly and they will jam against the edge of the tablet frame. And everything has been sized so the tablet will just slide in between these buttons, and then if you twist one at either end, it will just simply lock the tablet tight so that you can turn it into portrait mode if you want to do that, and the tablet shouldn't slip out. I haven't tried it, and I'm not sure why I would need to turn it into portrait mode anyway. So these were just simply turned on the lathe. I started off with 30mm stock. This diameter here is 22mm, and this diameter here is 11mm. But once again, it depends on how you've laid out the dimensions for your tablet holder. And I used a round high-speed steel 6mm diameter tool bit in a diamond tool holder, because it gives you this nice little radius at the end of the shoulder, or at the shoulder, and when it's sharp, it cuts the stuff beautifully. So I cut the spigot on these parts. I drilled and tapped M5, and that tapped hole is 11mm deep. Overall length of this part is 13mm, so you want to be careful that you don't thread all the way through there. And the tapped fitting in the end there is M5. After I had machined the spigot, I went over to the mill and I left the material oversized at 30mm so I had a better chance of gripping this in the machine vise. I zeroed out my cutter and I cut that rebate 1/2mm deep, and once I had everything set up, I could do all 4 of them very, very quickly. So let's get the thing together now, and you can just see the rough sequence of assembly. Now this part here has been sanded with an orbital sander. It's eventually going to get powder coated. All the metal parts will be powder coated together, and I'll probably sandblast everything before I do that. That just helps the powder coat to adhere much better, especially on these machine sections here. You want them to be a little bit roughed up, and the sandblasting does a better job. So to assemble it, we're going to put this M6 countersunk head screw through from the other side there, and we'll just spin that down. And we just got to line up our 4 screw holes. So these threads are actually in the 3mm sheet, so that the other side of this, when it's finished, is dead flat. So what I'll probably do here is sandblast this whole assembly. The whole thing's going to be powder coated as a unit, so I'm not bothered if the oxide comes off these cap head screws. So that's done. Now on this side here I will need to tighten that countersunk head screw down so it's below the surface there. So probably one important thing is that you don't feel any protrusions above that surface there when you're done. Now these little buttons just go in the 4 corners. So we've got an M5 screw coming through from the back. Now when you tighten these first 2 down, you need to look through here and get the flat oriented parallel to this short edge. And you don't have to be terribly precise, but you do want to get it pretty close. And they can be tightened down quite firmly. And with your other 2, just leave them loose at this stage. Now this big scratch here came off the back of the tablet, so must have been a bit of grit or something there. But that's alright, that'll get sandblasted off, so I'll just make sure that's clean. And you should be able to slide this through. So I'm going to leave my switches up this end, slide it through like that so I don't hit the switches. There it goes. So there's my switch. I'd say it's very close to the button, but I can still get at it, that's fine. If you're really pedantic, you can center the screen on that bit there. I don't think I'm that bothered. And then working with the back, we can just tighten up these 2 remaining screws, and that pulls the whole tablet down onto this sheet metal backing here. And usually that's enough to stop it sliding around. So that's not going anywhere, that's fine. But if you really need to, you can pivot one of these little buttons until that flat starts to crank round against this edge here. But I don't think that's going to move. So there it is, full assembly. And now that I've assembled it, I'm going to have to disassemble it and get it powder coated, but I wanted to show you what it looks like at this point. So that's it. Now we'll get this back on the arm, and I'll show you the whole thing after it's powder coated. And by the way, this has still got the screen protector on it. For the moment, I'm going to leave that on there. I imagine this is going to get really grubby and dirty after a while, but for the moment it's going to give me some protection on that screen. And I believe that one of the issues with touchscreens around machinery of this type is that if you get oil on your fingers and you touch the screen, that will sometimes leave an imprint, and it will also mean that whatever button you touched may remain active. So you do need to be careful and just try and keep your work environment relatively clean. And if you need to, you can buy these screen protectors and keep them on there and just chuck them away when they get damaged. So there it is, all done. Do you like my Allen keys? Okay, there it is after sandblasting. Here it is after powder coating. Here it is with the tablet attached. Right, here it is back on the mill, all finished. Here's me rotating the screen and moving the arm in a sort of a random fashion. You get the idea. Alright, that's it for this video. In the next episode we're going to be fitting the Bluetooth adapter, and it's going to go on the arm here, actually not here, it's going to go a bit closer to the mill. And being Bluetooth and wireless, we won't need any wire connection between the tablet and the brains of the unit. Now we're going to do a custom made case for that little Bluetooth adapter board that I showed you at the beginning of the video. So join me for that, it'll be interesting, and you'll be able to see this whole thing running and a summary of what it can do too. So thanks for joining me. I'll see you on the next video, and yeah, stay safe, have fun. Prezzo signing out.